Welcome back, Applied Calculus students. Today's lesson is a big deal. A big deal, because all of the functions that we've had so far are really straightforward. But what about when we try to take the derivative of something like this? Do we have to expand those brackets to multiply this out by itself, How can we do this? We use what's called the chain rule. And the chain rule says, if y is some function of u and u is some other function of x, then the derivative of y with respect to x, which is the thing we're normally trying to find, is the derivative of y with respect to u times the derivative of u with respect to x. Or we write it sometimes this way. When you have f of g of x and we take its derivative, so we have a composition of functions, f of g, and we take its derivative. That derivative is f prime evaluated at g of x times g prime of x. Two ways to look at a decomposition of functions. Let's go with something similar to what we're talking about. Find y prime if y is, let's do it, x squared plus 1 to the 5th power. This is a composition of functions. There's the outer layer. This is the outer layer. It's the thing that gets done last when you're substituting. And this is the inner layer. It's the thing where if I had an x value to substitute, I would substitute it there first. The outermost layer is the function that raises things to the 5th power. The innermost layer is the x squared plus 1. When we compose these, when this gets inserted there, we get x squared plus 1 to the 5th power. So if we can decompose the function, and I did say in week 1 that decomposing functions would be things we would need later, then we can treat these parts of our function separately. The derivative of y with respect to u is nx to the n minus 1, right? Its power comes down, power decreases by 1. Similarly, the derivative of u with respect to x, we can do that. That's just the derivative of a polynomial. What the chain rule says is that the derivative of y with respect to x is the product of these two things. It's 5 times u to the 4th times 2x. But u is x squared plus 1. 5 times u to the 4th times 2x. 5 times u to the 4th times 2x. The other way to spin this, off of this slide right here, we do the outer derivative, leaving the inside the same, times the derivative of the inside. Well, what's that mean here? Well, here, that means we do the outer derivative. The derivative of the outside is 5 times the thing to the 4th, and we leave that thing alone. When we deal with the outermost layer, 5 times thing to the 4th, we leave that thing inside alone, multiplied by the derivative of the inside. We get the same answer in a slightly different way. We get the same answer in a slightly different way. Looking for example 2. Find y prime if y is the square root of x squared plus 16. This is a composition of functions. The outermost layer is the square root. The innermost layer is the x squared plus 16. The outermost layer is the square root function. The innermost layer is x squared plus 16. And if we were to take this and substitute it there, we'd have the original function. Because we can decompose, we can write this in its layers, and we can deal with each layer on its own. The derivative of u to the 1/2 is 1/2 u to the negative 1/2. The derivative of x squared plus 16 is 2x. What the chain rule says is that dy dx is the product of these two things. 1/2 u to the negative 1/2, but what was u? It was this, times 2x. And sometimes that's written, we know that this is a negative 1/2 power, which means it's a 1/2 power, but it's in a denominator. There's a 1/2 and a 2, they cancel, and it sometimes appears in the back of the book like that. Now, the other way to think about the derivatives was to do the derivative of the outside layer, leaving the inside alone, and then multiplying by the derivative of the inside layer. But what is that here? Well, the outside layer is a 1/2 power. How do we take the derivative? 1/2 inside to the negative 1/2, and then we leave that inside piece alone for this step, and then we multiply by the derivative of the inside at the end. Oh, no, not yet. Let's go one more. Let's go one more. Let's do it. Let's make sure that we can do this. I'll pause and see if you can do this piece. I'll show the correct answer in about 10 seconds. Did you do something like that? The outside piece raises things to the 9th power. How do we take the derivative of such a function? It's 9 times the thing to the 8th, and then times the derivative of the inside piece. 9 times the thing to the 8th times the derivative of the inside piece. This is the derivative of u to the 9th. This is the derivative of 4 minus 3x. Okay, I'm going to do a second screencast. It's going to do some examples that help us find equations of tangent lines, a little bit of work with table data so that we know how to do that. And that will help supplement this, but this gives the basic understanding, and I'll see you when we gather.